This is the fourth lecture of Chapter 12, talking about organic chemistry. And we're still talking hydrocarbons, but now we're going to be talking about alternative hydrocarbons. So our hydrocarbon derivatives are formed when you have one or more hydrogen atoms on a hydrocarbon that have been replaced by an element or group of elements that are not hydrogen. So you can see here an example of that. So we've got methane, and that methane is reacting with chlorine in the presence, in this case, of sunlight. And so what we get is we get hydrochloric acid in this case, and then we get a new compound, and this would be a hydrocarbon derivative because it's still hydrocarbon because it's mainly hydrogen and carbon, but one of those hydrogens got replaced by the chlorine. So this next section is going to be looking at different hydrocarbon derivatives where, again, the organic molecule is a hydrocarbon, but one or more of these hydrogen atoms has been replaced. For most of these, it's just a single hydrogen atom that has been replaced to make this new derivative, this new molecule. So what these new sections are called are functional groups. So these are the atom or group of atoms in that organic molecule that have been replaced. And the reason why these are important is because these are what allow those molecules to participate in chemical reactions. So this is what gives the compound its chemical properties. So this is what makes them different from just a regular hydrocarbon. They usually have multiple bonds or lone pairs of electrons in order to allow them to react. So those lone pair of electrons will allow them to do that interaction to make bonds or transfer. The multiple bonds allow them to do like what we saw with the unsaturated and saturated comparison. So if you are an unsaturated molecule, so you have those multiple bonds, you're able then to transfer those multiple bonds over and bond with other molecules and transfer those to single bonds between the atoms. So you'll see as we go through these different functional groups, they'll be represented by general formulas and structures. So you'll see these little guys show up on the slides. You'll see a general formula like this. The R, that is going to be the hydrocarbon that it's attached to. And so this is the structure. The R is the hydrocarbon, generally the carbon that of that hydrocarbon that the functional group is attached to. And so we're not going to talk about this one, but this is an example, an organic halide. So this is the one we saw on this previous slide. So this is the chlorine. So we've got a hydrocarbon, in this case, attached to a chlorine. So this would be a functional group because you've got the chlorine, that's a halide. It would be a halide group, and so it has specific properties to allow it to react. So the first of the functional groups we're going to talk about are the alcohols. This is probably one of the groups that you are a little more familiar with. So this is an organic compound that is formed when you've got a hydrocarbon that is replacing one or more hydrogens on an alkane with what we call a hydroxyl group. And a hydroxyl group, as you can see, is just OH. An oxygen and a hydrogen that are bound together. So an alcohol can be identified because it is an organic compound, a hydrocarbon, where you have one of those hydrogens that's been replaced by an oxygen and a hydrogen that are bonded together. And you can see in the diagrams down here, they will be sitting next to each other. So we don't even show them with the single bond apart like this. We'll show them bonded together because they're working as a unit. That's why we call them a functional group, because they act together as a unit, kind of like when we talked about polyatomic ions acting as just one atom, basically. These guys are going to do that same sort of thing as a functional group. The name of the hydrocarbon that it is attached to, that the alcohol functional group is attached to, determines the name of the alcohol. So you can see here we've got what was methane, because this would have been 4 hydrogens around the carbon. So we swap out that hydrogen and we have our hydroxyl group, making this an alcohol. So instead of methane, it's methanol. So we add the "all" on the end to get the alcohol. So we've got methanol. This is ethane. So it was ethane with all of its hydrogens. We take it and swap it out for the hydroxyl group, and now it's ethanol. You can also see that they have alternative names down underneath: methyl alcohol, ethyl alcohol, and so on. So there are alternative names for them, but generally we are going to combine the name of the hydrocarbon with "all" to create the alcohol name. So a little bit of interesting stuff on alcohols. They are chemically similar due to that hydroxyl group, because they all have just that single hydroxyl group attached. Generally, now there are higher number alcohols that have multiple hydroxyl groups, but they're all going to have very similar chemical properties. One of those similarities is they are toxic to humans. So you may be familiar with this with some of the alcohols already. There is one exception, and that is ethanol. So methanol is toxic to us, the one from CH4. Ethanol, which is the next one up, is the exception. It is not toxic to us as long as it is consumed in limited quantities. So you know ethanol actually as alcohol. So ethanol is the alcohol that is found in things like beer, wine, and liquor. So in small quantities, ethanol is not toxic to us. However, in larger quantities, it is still toxic. So what organisms make ethanol? Well, if you're familiar at all with how beer and wine are made, you might know what organisms do this. It is yeast. And they will do this when they're provided with food like sugar and they're starved of oxygen. So yeast will make ethanol under those conditions. They'll also do this to make bread. This is why if you've ever been around when bread's being made, it kind of smells a little like beer, because they are actually making ethanol that gets baked off later when the bread is getting made. The small chain alcohols, so things like methanol, ethanol, propanol, isopropanol, those are going to be highly flammable, and they are water soluble. So that's why you can water down ethanol, in liquors and so forth. And that's why you can also light them on fire. As you get to the larger chain alcohols, the bigger ones, those properties do change a little bit because of the number of carbons that are in there. There is what we call gasohol. You actually have used it. If you go to a gas station, you've used gasohol, because today in the United States, your gasoline will contain ethanol. So you do have gasoline, which we saw in our previous lecture, which is made up of things like sorry, my brain is counting, hexane and octane and so forth that have been reformed, that 5 through 12 that have been cracked and reformed. But we do add ethanol into the gasoline in order to expand it a little bit as far as supply, and also to change the burn on it a little bit. We can't use pure ethanol in our engines though, because it burns too hot. A little bit more about alcohol, because a lot of people have always asked about what does the proof mean, because if you read alcohol bottles like rum and whiskey and things like that, it will say on there proof number. Proof is double the ethanol concentration by volume in alcoholic beverages. So that means that if it says that it's 80 proof, that means that that beverage is 40% ethanol, so 40% of the alcohol, and 60% water. So now you can, you've got a little bit of that extra information that you can, impress people with. So that means, for example, if it's 100 proof, that means it's 50-50. If we're doing distillation, so if you take alcohol that you've produced, which is usually pretty low in the amount of actual alcohol that's there, it's usually decently high in water content. So we distill it, so we boil off the alcohol and collect it and do that multiple times. We can actually create 190 proof. That's pretty, pretty decent. Oh, I will say though that consuming 190 proof is dangerous. It is at a high enough concentration that it can become toxic. If you come across anything that is 190 proof, it will say on there that you need to cut it. You need to mix it with water or some other liquid like juice or so forth, because that proof is too high for direct human consumption. You may also come across a product called denatured alcohol. Denatured alcohol is produced so that it can be used for various processes. It is made out of ethanol, which is the one that we can consume. However, it's going to have other materials dissolved in it as well. So you can see here in the list, for example, acetone and formaldehyde are just two of the chemicals that will be mixed into this. Why? Because it makes it impossible to drink. Because this denatured alcohol is used as a solvent in industry. They were adding things in it to not only make it useful for the industrial processes, but also to keep people from being able to drink this as a beverage. So keeping up, we're going to talk a little more in depth on alcohol than some of the other ones, because again, this is the one that you probably are most familiar with. You may just not be aware of it. So there are some other guys here. So glycol. So most of the alcohols that we come across that we are familiar with in our everyday lives just have one hydroxyl group. But then over here you can see this guy, ethylene glycol. Glycols are alcohols with two hydroxyl groups. So you can see two of the hydrogens have been replaced with hydroxyl groups with the OH. The one that you know best is this ethylene glycol that's over here, but you probably don't know it by that name unless you've read the ingredients on the bottle. It's the ingredient used in antifreeze. So ethylene glycol is one of the active ingredients in antifreeze to keep it from freezing. It is the toxic part in antifreeze. Then if you have an alcohol with three hydroxyl groups, like you see down here, this is called a glycerol, or the common name is glycerin. And here's where it gets really weird. So ethyl alcohol, or ethanol, you can drink in small quantities. It's okay, but large quantities toxic. Glycol, ethylene glycol, toxic. Glycerol, or glycerin. This is a byproduct in soap making. So we get this when we make different types of soap. And this is not toxic, at least in modest amounts. Obviously, everything is toxic when you get into a high enough amount, high enough dosage, but glycerin is actually added to our toothpaste and lotions and soaps and even candy. So it's obviously not toxic to the level that ethylene glycol is or ethanol is. So yeah, this is one of those weird properties of reactivity in chemistry. So one hydroxyl group okay to a point. 2 hydroxyl groups, deadly. 3 hydroxyl groups, we're okay again.